In the last video, we went over the basic structure of a program and we wrote our first program. In this part, let's start doing some more interesting things by introducing some variables and some things that may change over the course of the program. So again, here we have our sample program that just prints hello world, in quotation marks specifically. Now, it would be nice to be able to print things, but we need to be able to do a little bit more with that. So we want things that are going to change over the course of the program. In order to do that, we have things called variables. Now, in order to create a variable, you need two things. You need the type of the variable and then the name of the variable. At least that's the way it works in C++. So for an example, what I'll do here is I will create a variable called integer x. And so integer is abbreviated to int in C++. There are a few different data types that we have access to that are called primitives. Basically, they exist without us having to tell anything special about what they mean. So the compiler and the system know what this means in advance. An integer is one such example. Now, an integer is kind of a basic one that we can use, and it works exactly like an integer that you would see in math, and we'll explain more data types in a moment just to clarify that. So if I want, I can do math with it exactly how I would do math in something like algebra. What I need first, though, is a value for x. What I'm going to do here is set x, oops, I accidentally clicked on something, x equals 4. Now, if you want to set a variable equal to a value, you can do it using the assignment operator, this equal here. It doesn't really work exactly like how an equal works in math. It's a bit different. The way it works is that it takes whatever is on the left-hand side, which has to be a name. It can only be a variable on the left-hand side, and it will set it equal to whatever's on the right. So what this will do is kind of like it says, it will set x equal to 4. So x will be 4 after the line 9. Just to see that, let's print x using what we learned from the last video, which is cout, and then we have the arrow pointing to cout since that's where we want to send it, and then I will do an end line. So this should print 4, and if I run it, we should see that. Ran on a different monitor here, but you'll see it prints hello world, which we had previously, and then it prints 4. And I got rid of the line feed, so there's no space in between it. Maybe we'll add that back really quick. Oops. That goes here, right? So we can do math with this as well. Let's go ahead and print x plus 1. And you should see that this will print 5 because x is equal to 4, and if I print x plus 1, then it will equal to 5. So another thing about printing is that you can actually put expressions like this with math or some other things that we'll learn later, like function calls, and it will evaluate all of that before it prints it. So this will figure out what is x plus 1, and then it will print that instead of just x. Now, just to demonstrate that, I'm going to cout x after this anyways. And we should see that x will still be 4 even though we added 1 to it, because all we did was we added 1 to it here. We didn't update it in any way. Now if I run it, you'll see that we do in fact get 4, which is what x is equal to. We get 5, which is what x plus 1 is equal to. And then we get 4 again because that's what x is. Now, let's say we actually did want to update x. Then the way we can do that is saying x equals x plus 1. Now, again, this is where maybe the math comparison kind of doesn't work, because if we looked at this as an algebraic expression, then it would be equal to 0 equals 1, right? Because normally if you were to solve this algebraically, you would subtract x from both sides, and you would get that 0 would be on the left-hand side and 1 would be on the right-hand side. So it's important to note that when we write equal, when we're programming it, it actually means assignment. So again, we always need some kind of variable on the left, and then on the right, some kind of expression that it will set it equal to. So what the compiler or the runtime environment will basically do is it will say x is 4, and x plus 1 is 5. So we'll look at everything on the right side of equal first, evaluate that, figure out whatever it actually equals to, and then put that value into the thing on the left. So here, 4 plus 1 is equal to 5, and now x should be 5. Again, we'll double check that by running it, but we should see that when it prints x here, that we will get a 5 instead. So you'll see we get a 4 when we print x the first time, a 5 when we print x plus 1, and then a 5 here because we've updated x to be equal to itself plus 1. Okay, so now that we know that this works, let's maybe just keep track of the fact that we know that this prints 4, 5, and 5. So sometimes it can be a little bit confusing to program, and sometimes you need to make things a little bit more clear to yourself or to other people who are going to be reading your program later. The way you can do that is with a comment. The basic way to do it in C++ is with 2 forward slashes. So only one won't work, you do need 2. And then anything after that you can type and it will basically ignore it when the compiler tries to look through it. So here I'll put print x, we'll put print 5, which is 1 more than x, and then I'll comment this one with add 1 to x. You'll see if I run it in Visual Studio, it does end up green, and basically it just is something that the compiler ignores when it goes to compile it, and you can add these in to kind of keep track of what your code does. I like to throw these in if I'm going to solve a problem. I'll write down all of my steps in comments first, and then I will go and fill in code underneath the comments just to kind of make it work. Another way to do a comment in C++ is using slash and then star, and then you'll see that Visual Studio automatically put the second half for me, but star and then slash. So whereas the first one that we did here, the slash slash, only works until the end of a line, so you'll notice I put a slash slash and then print x. And then the next line is normal, kind of as it was in terms of the coloring. That's because this will still be code. Anytime you hit a enter or a line feed, it will end the comment. If you want a comment to be able to span multiple lines, then what you can do is use this slash and then a star, and you'll see that everything here is commented. Right, so that's how we can do a comment. You should use this to keep track of exactly what your code means. If something is unclear just by looking at it, what exactly it does. So I wouldn't put comments if what the code does is kind of obvious, and as you get more experience with programming, you'll probably understand what is considered like obvious to tell what it means just by looking at it, and what maybe requires a little bit of explanation. That being said, for the sake of this course, I do want you to comment most of your code, at least explain some of the stuff that goes with it. So from the rubric that we went over earlier, 2 of the things that I'll be grading on are your documentation, which just means the comments you have. Documentation just refers to comments and explanations of the code that you've written, and meaningful variable names. So I named this variable earlier x. If I had something that does something specific, then I want to name something that indicates exactly what it is. We'll go into that a little bit more in detail as we start doing some actual problem solving, but for now I'm just going to use the variable name x and y and the usual ones that you would use in algebra. Anyways, that would be what comments do, or comments are, and what they do. Let's go a little bit more into variables and the other data types we have here. So I've set a variable x equal to 4 up here at the top, and I have declared it as an integer. Now in C++, when you declare the type of a variable, you can't change it while it's still in the same scope, which for the sake of our thing here is just the entire program. Anywhere between these 2 curly braces, that is where x is. So I can't go and change x into some different kind of number or a message or something like that. It has to stay an integer the whole time it runs. Now, because of that, I can't do things like set it equal to things that aren't an integer. So an example of that, we said earlier that putting double quotes around something is an example of a message or a string. So if I wanted to set x equal to hello world, which was this message we had up here, then it doesn't allow me to do that. So it says a value of type constant character pointer, which is this thingy, cannot be assigned to an integer. And that would be right, because what does that really mean to set x equal to a message? Then, that's not super clear what that means. On top of that, we also can't set x equal to things like 4.2, because 4.2 is not an integer. Even though it is a number, it's still not an integer. Let's take a look at some of the other data types that exist in C++, and we'll just explain what they mean. So what we had earlier was int x. I'm going to put the integer part in blue, and then I'll put the name in red. So this is a variable declaration. It makes a new variable, and whenever we do that, that's called a declaration. Now there's another thing called a definition, and we'll get into that in a second, but for the time being, this is what a variable declaration will always look like. It will have a data type, something that tells it what is this thing, what kind of data should it hold, and how should I be able to use it, and then we have a name, which is how we address the variable. So I'm only able to ever use x in my code. If I try to do something like print y here, then I can't do that because it doesn't exist yet, right? It hasn't been declared. And here it says it hasn't been defined either. Now, if I wanted to define x, or at least declare it, what I can do is simply put a comma and then put a y. So if you want to declare multiple variables in the same line of code, you can simply put a comma in between them, or you can also do it on another line like this. Now you'll see it even has a little green arrow under it here, or green underline, and that's the reason. The reason that is because y doesn't have a value yet. I've set x equal to 4, but I haven't set y equal to anything. So you need to always set a variable equal to something before you use it. If you don't do anything, then it kind of depends on what the compiler does, whether it will assign it a default value or whether it just means nothing or it's just random garbage. In this case, Visual Studio's compiler will set it equal to 0, but the compiler on Sally should just make it random garbage. That being said, we should always initialize our variables, so just for the sake of that, I'm going to set y equal to 0. Another thing you can do, sorry, I clicked on that. Another thing you can do is actually do the equal in the same line as the declaration. So this is a declaration. I'll move this up one line. When you set something equal to something, that is a definition. And you can do a declaration / definition in the same line if you use an equal when you actually do the variable. So here I've both created y and then also set it equal to 0. This is also called a initializer. So when you first set something equal to something, that would be initialization, that is giving an initial value. Okay, so that's basically how we declare a variable and the ways that we can do it. I'll do another example with commas in a moment here, but you'll always need a data type. So you need to tell what exactly is the thing, followed by a name for the variable. And we can have some extra stuff in front of it that we'll go over later in the course, but for the time being, that's just how we're going to declare our variables. Now, there are a few different data types that we can use that are built in. So data types in C++ include integers, longs, floats, doubles, booleans, and that should be about it for our basic ones. Unless I'm forgetting something, but I don't think I am. So an integer and a long are basically the same thing, and a float and a double are basically the same thing. The only real difference between a long and an integer, and the same thing with a double and a float, is that the long holds more data in it. So you've probably heard before that a computer works in binary, right? It has zeros and ones. An integer is consistent of, on modern hardware, 32 zeros and ones, whereas a long is 64, and same thing with a float and a double. Those would be 32 and 64 respectively. Now what an integer is counting numbers, so 0, 1, 2, 3, stuff like that, but also -1, and any sort of negative number, it falls under that 2, ... So -2, -1, and then any number there as well. So integers are only able to hold counting numbers. They can't hold decimal points like 1.4 or pi or e or anything like that. The number that we do for that, or the data type that we do for that, is a float and a double. So those can hold things like 3.15, 1.6, -0.7, 4, that kind of stuff. An integer, because of that, is able to hold more numbers as opposed to a double, but it is not able to do fractional parts like the thing after the decimal point. So if you need to be able to do decimal point arithmetic, then you're going to have to use a float or a double. And if you want to do things where you need to count or do wraparound, then you'll need to use an integer. And we'll explain some use cases of integers later, because there is some special rules as far as adding and subtracting and multiplying and stuff like that goes. So we'll have to address that later. Now the last basic data type we have is bool, and I knew I forgot one, character. We have a character as well. Boolean can have two different values. It can have a value of true, which perhaps would look a little bit better in green. It can have a value of true, or it can have a value of false. And I should do those as lowercase, because in C++ the word for it is lowercase, I think. So when we do a Boolean, it can only be true or false. That is, it represents whether something evaluated correctly, or maybe that's not the right term, if something was true or something was false. So an example of that might be, is x greater than 1? Now, if I was to write this, it would evaluate to a Boolean. We'll double check it in the actual program in a second. And if I was to use the x that we had in our program, then it would evaluate to true, because yes, 4 is greater than 1. And the last data type we have here is a character. So a character are individual characters. So that could be the letter A, that could be the letter B, that could be a period, that could be a comma, that could be the line feed that we went over earlier, which was the \n, and that could be something like space. So these are all examples of characters. They represent one individual part, or like one individual letter. Basically, if you can look at the keyboard and see it, then it would be a character. And this includes both the lowercase version and the uppercase version as well. So uppercase B and that kind of thing are also in there. Now, a character can only be a single character at a time. I can't have multiple, so I can't make it like A and B together. It has to just be one. The way we designate a character is with these single quotes. So whereas a string, which was the kind of message that we printed in the last part, has to have the double quotes, this one has only single quotes, and it represents only one letter. Now, something else we'll just note is in C++, these are a little bit different in the way that they're handled compared to other languages. So a Boolean is secretly an integer. And a character is secretly a byte. If you're familiar with binary already, then you should know what a byte is. And that's what a character is in C++. So if you ever need to use a byte data type, which you might on occasion, the more you get into computer science, the more you'll see it has applications. A character is how you do that in C++. So there's no designated byte type, it's just called a character. A Boolean is secretly a integer. So the true value is actually just the number 0, and false should be everything else. That can be important because you can get some weird side effects in C++ because it allows you to do that, and you'll see that some people do it as kind of like a trick in C++, is they'll use a Boolean and they'll set it equal to something that's not true or false. They'll set it equal to, you know, another value. So just be aware of that. You should try to use true and false. It looks nicer and it's more clear as to understand like what it means. So you should always try to use true and false when doing a Boolean, but you do have the option to use a number if you would rather do that. Let's end off here by doing each of these data types in an actual program and just seeing what they look like. And then we'll go over how to actually do more things with them later. I've already done plus with an integer. Any sort of other arithmetic operator like minus or divide or times also works, and we'll go over the specialties that have to do with those and floats in the next video. But if you want to practice on your own, just know that those all do work. Now let's do an example of a float. So I could do something like float A, float B. So this will create a float called A and another float called B. And you'll see that I can set that equal to decimal numbers, and I can also set it equal to numbers that are integers, since integers are themselves floats. They are decimals. Right, so we can create floats. We can also create booleans. So I could create a boolean called flag or something similar, and I can set it equal to something like true. And then for the last example, we'll do something like character B equals, let's do it something like this, letter C equals, and again, like I said earlier, it is the letter C like that. So there you have it. These are our primitive data types. They're the ones that are built in, and we'll be using these a lot over the course of the semester. Now we'll go into actual uses for these in probably the next video, but for the time being, this is at least how you create them. One last thing that we'll maybe note before we move on is that you can also create constants. So like math, we usually have variables and constants. So in math, a variable is usually an unknown, but for here, like the name implies, it can vary over the course of the program. So x, for example, starts off as 4, and then later we reassign it here to x equals x plus 1. So we've made x vary by changing its value to 5. But maybe you want a variable that doesn't change. And so, like in math, we have something called a constant, and what a constant is it is a variable. It is treated the same way by the compiler, but the only difference is you are not allowed to change it. So I will do an example of that here. The way you do that is with the keyword const, and then you again give a data type. So here we'll just say an integer again, and then I will give it a name, so I'll call it constant x. I realize I haven't explained some naming conventions, so maybe we'll finish with that, but let's finish this really quick. If I do that, we get constant x equals 0, and now I have a variable that is an integer. So again, we have always the data type of the variable, the name of the variable, and then here I've done a definition as well as a declaration by setting it equal to 0. So this stuff is basically the same as what we've learned so far. The constant just means that I'm not allowed to change it after this first line. So if I went down here and tried to do something, actually let's do it right next to where it was. If I was to go under here and type in constant x equals 1 plus 2 or something like that, then you'll see it gives me an error. And it says expression must be a modifiable value. And because it's a constant, it's not modifiable. So whenever you have a constant, you can't set it equal to anything after you first initialize it. There are other ways to do this that are a little bit more efficient, but this is kind of the basic way that we'll do it for now. Last thing I should mention is naming conventions. Now, you don't always have to name things like I do. In C++, there is a specific naming convention. I don't remember 100% all of them, I'm going to be honest, and I'm going to use the naming convention I usually use, which is a name, and then anytime I start a new word, I just capitalize it, which is called camel case. Whenever you create a name for a variable, there are a few rules that you have to follow. So it has to begin with a letter for one thing. So if I wanted to create a variable called int 9x or something like that, then that's not allowed because this variable starts with a letter, or sorry, starts with a number and not a letter. So this is not valid. You can, however, start it with an underscore. That is allowed, and you'll see that people do it quite often. I'm not a fan of it, but you'll see that people do it pretty often, especially in C++. So you can't start a variable name with a number. You also can't start it with a any sort of character that's defined by the language. So things like plus aren't allowed. So I can't say plus x equals 3 because plus is something that we use for addition. So it's not allowed to be used before a variable name because then it kind of gets confused as to what that means. So same thing goes with any other kind of operator, minus, divide, times, not, greater than, and that kind of stuff. And we'll go over all the operators as we come to them, but you can't start with an operator. You also can't use any word that's defined in the language. So I can't name my variable int equals 3 because int is a word that we've used for declaring variables, and it represents the data type, right? We've been putting it beforehand to say what kind of variable this is. So I can't name the variable int as well because it gets confused, and that word is what we call reserved by the compiler or the language, and so it's not allowed to be used as a variable name. So same thing goes with bool or floats. They'll all give you errors because these aren't valid names. They're defined as things that are in the language. Now you also need to be careful because I can do something like cout, which is the thing that we used for printing. I can actually rename that because that is a variable in another library. And if it doesn't exist in the same scope, which we'll go over what scope means at a later date, then you can rename it and it will break some of your code. So when you go to name variables, again, make sure they're meaningful, make sure they capture something about what it is that you're programming, they represent what you're going to be using it for, and that you are careful not to use it with another variable that exists in a different namespace. So we'll be using this namespace standard that I showed you in the last part for the entire semester, but just know that in C++, it is considered standard not to actually use this. It basically just keeps us from typing out some extra stuff every time we type any variable that belongs to it. And in order to avoid that error that I just made where I made another cout, then it's common to not use the namespace and force you to type out the whole thing so you know exactly what namespace that variable came from and you don't accidentally do what I do and just redefine it. Anyways, I think that covers about all the basics for variables. So in the next part, we'll go over some of the operations we can do on the specific data types. So math that we can do with integers, and then other things we can do with characters and some other operations.